Okay, so in this video, we're going to pick up where we left off and look about what is a limit. So just as a reminder, the limit is the expected y value a function reaches. And what has to happen is that our curve coming from the left. So when we come from the left, we start on the left and we trace left to right, and we go to that x value we're interested. And then we do the same from right to left and go to the x value interested. And if they approach the same y value, then we say the limit exists, and the value of the limit is whatever that y value is. And how we always write it is write LIM for limit. We put x arrow and then whatever x value we're interested in. And so we say this is the limit as x approaches 2. So again, we don't care what is happening exactly as 2, but as we get close to 2 from both sides, we're like, what should the y value approach, or what does it approach? And then we put f of x or g of x or whatever function we're looking at here. And then we put equals whatever that y value is at that point. And so again, this is our notation for limits. Sometimes, like when I write it, I put it under. Sometimes with computers, they put it like kind of a subscript on the limit. Either way is fine. Okay, this is whatever function we're talking about, and this is the y value it's approaching. Again, it's not the actual y value because the y value might not exist, or it might be somewhere else, which is fine, or it could be filled in at the 0.24, and that's fine as well. So the initial definition said the limit from the left and the limit for the right have to be equal. And so we have two types of limits, the limit from the left and the limit from the right. When we write the limit from the left, we use a little like negative sign on the A, and it's after it, okay? And it's like a superscript. And that means we're coming from the left. And when we're coming from the left, that means we're going left to right, and we trace our function and we get until we get to the whatever x value they say, and we say, okay, what y value is that approaching? And this again is my function f of x. And we can see this is a piecewise function where it has this, it's called a jump. And if I trace this function from the left, like going left to right, and I see what y value it gets to, well, the y value at A is 3.8. Now, we also need to approach it from the other side. So we say approaching from the right, what we do is we write x arrow A, and then we put a little plus sign, and that means from the right. So the plus sign means I'm coming from the right and going right to left. The minus sign means I'm going from the left and I'm going left to right, okay, of my function. And so I'm going to start this time on the right. I'm going to trace my curve and see, okay, what y value is it getting close to? And this one is 1.3. Okay, and so we have a left limit and we have a right limit. And we only want the left or right is if they have the minus or the plus sign. Okay. If they just said this, the limit as x approaches A of f of x, okay, that's the limit of the entire function at A. And so for this to exist, these two values have to be equal. The left-hand limit has to equal the right-hand limit. Okay, so for a limit to exist, the limit as x approaches A from the left has to equal the limit as x approaches A from the right. Okay. And if it doesn't, we usually say it does not exist. Okay, we don't say undefined, we say it does not exist. And the shorthand we usually use is DNE for does not exist. Okay, so if they're not the same value, the limit overall does not exist. So if we look at this one, it's kind of the same idea. I want the limit of f of x as x approaches 3. It has the little minus from the left. Then I want it from the right, and then I want the overall. Okay, so I look on the x-axis and I find 3. And so I'm going to approach this x value. And so I'm going to start from the left and go left to right. So I'm going to start on my curve and go left to right. And I'm going to see, okay, what y value does it approach? It doesn't matter if that y value exists or not, but just what y value is it hitting from the left. And if I look, okay, this y value is 3. So this would equal 3. If I come from the right here, I want the limit as x approaches the 3 plus from the right. I'm going to trace this function and go to the right. Again, it doesn't matter that the y value does not exist, but that y value is at 6. And so the limit from the right is 6. And then it says, okay, what is the limit at x equals 3 overall? And because they're not the same value, we say dne. And if you have to explain why, you say the limit as x approaches 3 from the left of my function doesn't equal the limit as x approaches 3 from the right. And this is the notation that we use. The left-hand limit doesn't equal the right-hand limit. And then the last question is f of 3, and f of 3 is more of a pre-calculus question, but it will be asked a lot in this class as well. So f of 3 is what is the y value when x equals 3. That's what it means. It says find the y value when x equals 3. So if I go to x is 3 and I find this y value, okay, this is an open circle, so it doesn't exist there. So it exists here, and that's going to equal 3. The y value when x is 3 is 3. So let's look at another example. So we're going to determine the following. It says the limit as x approaches 1. Again, there's a minus sign. It's a little bit hard to see. From the left of this function, which we're calling f of x. And so I start on the left of my function, and I'm going to get until I get to x is 1. So I'm going to trace this until I get to x is 1. And I'm going to say, okay, what y value is this? Again, it's always the y value for a limit. And this is -2. So I'm going to say equals -2. Then I'm going to go the limit as x approaches 1 from the right. So this again is the right. This is the left. So I go right to left, trace that. Okay, what y value am I hitting when I get to 1, which again is -2. And because these are equal from the left and the right, they meet up at the same point. The limit is -2. But then we want f of 1. Well, if I look at my function, if I just kind of erase so you can see a little bit better, there is an open circle here. There's no filled in circle. So f of 1, there is no point. And usually we call it when there's not a point undefined. Okay, instead of a limit does not exist when it doesn't exist. A point we say is undefined if it doesn't exist. Okay, there's no y value at 1, so we call that undefined. Okay, so then we're going to look at this graph, which has a lot of different limits within 1. The other ones were a little bit easier to say because we were really focusing on where the function kind of changed a little bit, but this one is not as much the case. So you really have to pay attention to the x value. So this first one says the limit as x approaches -3 of my function f of x, and this whole function is f of x. It doesn't say from the left or the right, so I need to check both ways if that's the case. So here x value is -3. I'm going to check both ways. So as I come from the left and trace my function, I'm approaching this y value of 3. And if you come from the right now, if you go on your curve, you would like start here, go over, and then you would jump down to this curve. You have to stay on the curve. And then I come from the right till I get to that point, and that's also approaching that y value of 3. So this equals 3. This one says find the limit as x approaches 5 from the left. Okay, so this is the left of my function. So I'm only coming from the left of 5. Okay, so here again is my x value of 5. I'm starting on the left. Again, you don't have to start all the way to left, but if you do, you just stay on the function and like jump and trace the function. Okay, and then I come from the left, and as I do that, the y value is going to 6. Okay, and this one we could only do the left. There's no function on the right. So again, that would be does not exist if it asks for 5, which is right here. The limit as x approaches 5. Well, there's nothing coming from the right. So again, this does not exist. because there's no right-hand limit, so it can't equal 6. So then we want the limit as x approaches 1. So 1 is here. And we would trace, okay, from the left, because we want the overall limit. And then from the left, as I trace from 1, I'm approaching this y value of 2. And if I come from the right and trace it as I get closer and closer to 1, I'm also coming to 2. Okay, so this equals 2. And again, that point doesn't matter. So like, if it asks for f of 1, you would say undefined, but it doesn't matter because I'm looking at the limit. Okay, the limit as x approaches 0. So we're going to erase some of my markings so that you can see 0 better. So if I come from the left of 0, I trace my function. I'm going to skip up to it, and then 0 is here on the x-axis. So I'm getting here, and the y value is 3. And if I trace the other way from the right and see the y value also approaches the same value, which is 3. Okay, and that point exists, which is fine. Again, it doesn't matter if it exists or doesn't exist. So then we have the limit as x approaches -1. Okay, notice if the minus sign is in front of the number, that just means it's a negative number, versus like here, that means I'm coming from the left. Just note the difference. So -1 from the right, if we trace here and come down, -1 is here, I would get to this y value of 1. And so I'm just going to write that out. The limit as x approaches 1 from the left is 1. But if I come the other way and trace it, the limit as x approaches -1 from the right sorry, this should be -1. Is approaching this y value of 2. Okay, so again, for this limit, we would say does not exist, because if I wanted to write the reason over here, I'd say the limit as x approaches -1 from the left doesn't equal the limit as x approaches -1 from the right. Okay, and you need to put f of x. You always have to put the function. Students love to leave that out, but you always should put the function there. Okay, the last one is x approaches 1 from the right. So from the right, I'm coming this way. So if I trace from the right, x approaches 1, that y value is going to be 2. And just kind of quickly for some, if I was like asking you for f of -1, and let me erase all my markings so you can see this diagram better. Okay, so f of -1 means what is the y value when x is -1? So if I come to -1, the y value is here. That's the defined point. And so that would be 2. Now, if I said f of 0, I go to 0 and I find the y value, which is just a point on the curve. It's filled in. It doesn't have to be a big circle. So that would just be 3. Just like if I said like f of 3, in that case, I come to 3 and I find the y value, which is defined. It's just on the curve, even though it's not a big point. And so that is -2. Okay. And again, if we said like f of 1 or f of -3, those would be undefined. So that's kind of the basis of finding limits from a graph, and then we will get to finding the limits algebraically.